In topic 5.5, we'll be learning how to use triangle congruence theorems to prove that two different triangles are congruent. So you can tell two triangles are congruent just by looking at the images of the two triangles, if they have specific things congruent or in common. So for example, you can use SSS, which means side, side, side. If the two triangles have all three sides congruent, then they are the same triangle. You can also use SAS, which stands for side, angle, side. Here you would have two triangles that have two sides congruent and the angle in between those two sides congruent. So it has to be the angle that's in between those two sides. That's where they get the name side, angle, side. So it goes in order. Angle, side, angle is similar. It's just now you have a side in between the two congruent angles. So you have an angle, a side, then an angle. Angle, angle, side, or AAS, is when you have an angle next to an angle next to a side. So these are four of the theorems you can use to prove triangles are congruent. Now, side, side, angle, and angle, angle, angle don't work, so don't try to use those, because you can have two triangles that have two of the same sides and one of the same angles. But if the angle is not the angle in between them, then the angle in between them could technically measure higher or lower. You can't use angle, angle, angle because you can have a big triangle and a small triangle with the same angles, but the sides could be completely different, as you can see in the image there. And one other theorem you can use if you have a right triangle is you can use hypotenuse and leg. In other words, if both of them are right triangles and they have the same hypotenuse, and one of their legs is also proven congruent, then you can infer that the two triangles are congruent. So we're going to be practicing using these today while looking at pictures of triangles. So here in example 1, we have a picture. Let's see if one of those theorems can be used. So I notice this one's marked with a 1. So that's a side, then an angle, and then a side. So if I went in order using the way they were marked, this is side, angle, side, or SAS. So these two are congruent. And that would be using side, angle, side. On question 2, if we look, here we have a side, a side. Now, if you notice, the third side on both triangles is the same. So I can actually mark this third side the same because it's on both. So this one's actually SSS, or side, side, side. On picture 3, we have marked a side and an angle on both. So they didn't give us something, but if you look at this picture, if you look at the two triangles that are shown, they make vertical angles. And remember, we learned vertical angles are congruent. So because those two are vertical, they're congruent. So now if you look at how our pictures are marked from left to right, we have a side, an angle, and another angle. We wouldn't call this SAA. If you look back to our theorems, we have one called angle, angle, side. So I'm going to call this AAS for angle, angle, side. In our next picture, we also see vertical angles. So I'm going to mark those vertical angles congruent. So now we look from left to right. We have side, side, angle, or angle, side, side. Which is not one of the theorems you can use. So if you look back here, side, side, angle doesn't exist. So here, even though we see those, side, side, angle doesn't exist. So these ones are not congruent. I mean, they could be, but we don't have enough information to say they're congruent. Our next picture, I noticed right away that these are right triangles. So since they're right triangles, I can try to check if I have the hypotenuse in the leg. Here, the angle that's across from the right angle is always the hypotenuse. So these both have the hypotenuse marked the same. And then they have this leg in common. So these two are also congruent triangles, and that's through hypotenuse, leg. In our next picture, we have vertical angles. So I'm going to go ahead and mark those vertical, congruent. And now if I check how these are marked, I have angle, side angle, angle, side angle. So these are congruent by angle, side angle, or ASA. And if you need to when you're doing these, because they're new, you can go back and check the notes. So you could check here. If we have angle, side angle, here we do. So then we can use that to prove these are congruent triangles. Our next picture here, picture 7, they show two angles congruent in the triangles, and they also have this common side. So since they have this side in common, I can mark that side congruent on both. So this would be angle, side angle, or ASA, just like the last one. On our next picture, these have a common side, so right away I'm going to mark that common side congruent. And now we check, we have side, angle, side on both, side, angle, side. So this would be congruent using side, angle, side. And now we look at our last picture. Here we have angle, angle, side, angle, angle, side, which is one of our theorems. So those are congruent by angle, angle, side. In this next section, we're going to be doing the opposite. So that we already know that our triangles are congruent, we're going to say what other information would have to be given to know that this is true. So for example, in question 10, it's saying it wants us to use SAS, side, angle, side. So here we have a side. Here we have vertical angles. So to complete side, angle, side, these two sides would also have to be congruent. So we can write a statement about that. So I could say that side XZ or ZX needs to be congruent to side XV or side VX. Our next image wants us to have angle, side, angle. So we have this angle, this side in common. We would need another angle there. So I'm going to mark this new angle because it's the one we need, and it would have to be congruent to this angle. So now if I name my angles, this would be angle CBD. This one here would be angle BDA. So we want those two angles to be congruent. In our next picture, we want SSS. So we know they already marked this side. We know this side has to be congruent because it's the same. So that means this third side here, both triangles would need to be congruent for SSS to take place. So side MQ would have to be congruent to side PQ. Our next one wants hypotenuse and leg. Well, they have this leg in common, and they're 90-degree or right triangles. So we just need to prove that the hypotenuses are common. So the hypotenuse over here is DG. That would be need to be congruent to the hypotenuse over here, which is FG. This next one wants angle, side angle. They gave us these angles. So we would want these sides to be congruent. So JL would have to be congruent to side LM. And we already know that these angles here are congruent because they're vertical angles. So we just need to prove that JL is congruent to LM. Our next question wants us to use side, angle, side. So here we have side, and we know this side's also congruent. So we would just need to know that the angles in between those are congruent. So this angle up here, I can call it angle QRS. This angle down here, I can call it SRT. So I would need to show that angle QRS is congruent to angle SRT. In our next image, they want angle, angle, side. So we know that this angle and this side are congruent because that's this common side. So we would need to prove that this angle here and this angle here are congruent. So that angle BAD and angle BCD are congruent. In our next picture, these are vertical angles and they're both 90 degrees. So I can use the right triangle theorem, which is hypotenuse and leg. We already know that these legs are congruent. So I would just need to prove that the hypotenuses are congruent. So the hypotenuse over here is VW. And over here would be ZY. So VW has to be congruent to ZY. Now we look at our last image. They want side, side, side. We know these sides are congruent. These sides are the same, so they're congruent. So we would just need to prove that the third sides are congruent. So side PQ would have to be congruent to side QR. So these are just really looking at the pictures and analyzing them. If you need to mark them, do so. So like here, if you need to write out the little letters to help you come up with it, you can. Like for example, if I go down to another one, here I have angle, side angle. So I would mark them in one of the triangles just to make sure you're on the right track. Like here, this would be angle, angle, side. Some students might want to say SAA if you need to. If you're not sure what way to order them, look back at your theorems. You'll see it's AAS, not SAA.